Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into a little lesson here on linear functions, rate of change, and also graphing a linear function here. So we have three goals, really. We want to develop a table of ordered pairs given a function, a linear function that is. We want to determine the rate of change from the table, and we want to graph the function. Okay, so three separate things. There's a lot of arithmetic. All right, so if you're at home watching this video, or even in class, if that's the case, you could pause and play and go at your own pace. All right, so let's get started. Here we go. Number one here. So what we want to do is take this given function here, a linear function, y equals negative 2/3 times x plus 1. We want to develop the table values, calculate the rate of change of the table, and then, of course, plot everything and graph your linear function. And I'm also going to use Desmos too, all right, to verify. Okay, so we're going to use, all right, Desmos, all right, to verify everything I say. All right, and Desmos is easy to use. So do that. You got to have Desmos here. So be able to do that. All right, make sure you're signed in. And the name, your name should be in the upper right, like my name, Mr. Ainsworth here, is in the upper right. And this is section 2-3, so just type a number in, click on save, type in 2-3, okay, linear functions, okay, just like I'm doing right here, very easy to do, that way you can save your work, all right, and then we'll use that here in a minute. Okay, so let's go back to the lesson here, and let's do everything by hand first. We only use that technology at the end, okay? Do everything by hand first and do everything mentally because you have to develop your skills, all right? All right, it is time to develop skills. Look at the person next to you and say, it is time to develop some skills. All right, so here we go. We're going to take our x values and substitute in our function. Our function y is equal to negative 2/3 times whatever x is plus 1. All right, so let's put parentheses around x and then add 1. So 2 times whatever x is, 2/3 times whatever x is, plus 1. All right, so here we go. We're going to take 6, all right? We're going to take our x value and substitute it in. Here we go. So negative 2/3 times negative 6 plus 1. Now, there's two ways to do this. Okay, so first of all, the thing you have to know is that you're multiplying two negatives, and a negative times a negative is a positive, so cancel them both out. That's the first thing. Handle the signs. Okay, next thing, we can multiply first, then divide. So 2 times 6 is 12, divided by 3 is 4, and then add 1, gives you 5. That's one way to do it. Or you can divide first, then multiply. Divide first, then multiply. Now, if you do that, here we go. We're going to take 6 divided by 3, that's 2. 2 times 2 is 4. 4 plus 1 is 5. Okay, so that when I cross those out, and I show the cross canceling here, 6 divided by 3, because 3 is in the denominator, so it's division there. 6 divided by 3 is 2, times 2 is 4, plus 1 is 5. And there we go, and that's how it's done. Okay, so now let's do it again. So negative 2/3 times negative 3 plus 1. Okay, you take your x value, substitute in the function, okay, substitute in the function wherever you see x, and then you evaluate it. All right, you got to get good at the arithmetic. So here we go. First of all, cancel the negatives. Right, a negative times a negative is a positive. All right, 3 divided by 3 is 1, times 2 is 2, plus 1 is 3. There we go, and that's how it's done. So now let's take negative 2/3 times 0 plus 1. So anything times 0 is 0. Okay, so obviously this is 0. 0 plus 1 is 1. And again, you can see a pattern what's going on. We get 5, then 3, then 1. It's a decreasing function, right? Because of the negative slope there. All right. If you guys didn't notice that negative 2/3 is a slope, you're going to see that pretty soon here because we're going to take a look at the rate of change. All right. We'll talk about that in a minute. So now negative 2/3 times 3 plus 1. So I'm going to divide first. 3 divided by 3 is 1 times negative 2. That's negative 2 plus 1, or negative 1. Next one, negative 2/3 times 6 plus 1. All right, and so again, I want to divide first. Not that you have to. You can go negative 2 times 6 is negative 12, divided by 3. That's negative 4, plus 1 is negative 3. You could do it that way, or you can divide first. 6 divided by 3 is 2, times 2 is negative 4, and negative 4 plus 1 is negative 3. So you could do it any way you like, okay? So you can multiply first or divide first. It doesn't matter, but just follow the order of operations. All right, so negative 2 times 9 is negative 18, divided by 3 is negative 6, plus 1 is going to be negative 5, okay? Or you can go divide first. 9 divided by 3 is 3, times negative 2 is negative 6, plus 1, and that's negative 5, okay? All right, so now let's take a look at the rate of change. So the rate of change of a linear function is the slope. That's what I was talking about in the first lesson. So let's write that down. It's equal to the slope of the function, and the slope of the function is equal to delta y divided by delta x. Okay? Delta y divided by delta x. And so what would that be? So let's take a look at it. Here we go. Let's take a look at delta x first. Okay, delta x is the change in x. From negative 6 to negative 3, you're moving right on the number line. So that's plus 3. From negative 3 to 0, you're still moving right, plus 3. From 0 to 3 is plus 3. From 3 to 6 is 3. From 6 to 9, we add 3. So delta x, oops. So delta x is 3. It's constant. Okay, I talked about that in lesson 1. So delta x is 3 here because we have equal intervals of x right here. And now let's take a look at the change in y. Okay, so from 5 to 3, we're decreasing there by 2. That's why it's a minus 2. From 3 to 1, we're decreasing, all right, minus 2. From 1 to negative 1, we're decreasing minus 2. And again, we keep going on left on the number line. We keep decreasing by 2. All right, that's called delta y. All right, so delta y is negative 2 because it's decreasing. Now we take those values and we write the slope. All right, and the slope, or the rate of change, okay, is equal to delta y, which is negative 2 divided by 3, and you get negative 2/3. And so notice that the slope is this number right here, negative 2/3. And that's why we have this linear function right here. Y is equal to m times x plus b. This is what you saw back in middle school. So the slope here is m, which is your rate of change, okay, ROC for short. All right, which is delta y over delta x, the change in y over the change in x. So you have to get used to the lingo here. All right, the question is, what's that plus 1 represent? Okay, so let's figure that out. Okay, so let's plot the points. And hopefully you guys remember how to plot points. So our first one is negative 6 comma 5. So go left 6, all right, up 5. All right, that's negative 6 comma 5. Next one is negative 3 comma 3. So go left 3, up 3. 0 comma 1 is up 1 from the origin. 3 comma 1 is right 3, up 1. Ooh, oh, excuse me. 3 comma negative 1 is right 3, down 1. Okay. And then 6 comma negative 3 is right 3, excuse me, right 6, down 3. Sorry. And then the last one is 9 comma negative 5. So right 9, down 5. All right. That's 9 comma negative 5. That's my last point in the table. All right. And notice there, they line up in a line, and that's why we call it linear. Okay. They line up in a line, and it's a linear function. So sketch it. And there we go. And there is the sketch of the linear function y is equal to negative 2/3 x plus 1. The question is, what's 1? All right, so tell the person next to you, what does 1 represent on this linear function? What does it represent on the graph? Okay, and so if you told the person next to you, all right, that it is the y-intercept. Okay, it's the point where the function meets the y-axis. Okay, it's where it crosses the y-axis here. Y-axis here, x-axis here. All right, then you got it. Okay, so this b value is your y-intercept. All right, the coefficient of x here is called the slope. Okay, it has another name called the rate of change. Okay, and that is your general linear function right there. Y equals mx plus b, that's called slope-intercept form. Slope-intercept form for a linear function. Linear function. Okay, all right, there we go. So this is should be a big review here. You guys should have seen this in middle school. All right. But the question is, did you really get good at it? And can you do all the arithmetic in the table here easily? And so that's what we're concentrating on now, is getting really good at it, mastering the basics, getting good at arithmetic so you can like apply it to bigger and better things, which we're going to tackle later on. Okay? So let's get some experience now. All right? So if you like, at this point, pause and play the video in class. You can pause it and then play it when you're ready, and then correct your mistakes if you made any. Okay, so go for it. Pause the video and then play when you're ready. Okay, so I'm assuming that you already did it here, so we're going to take 1/2, all right, multiply -4, and then add 3. Well, to do that, we got to take -4 divided by 2. That's -2 times 1 is -2 plus 3, and that's 1. Okay, next one, 1/2 times -2 plus 3. So 1/2 of -2 is -1. All right, -2 divided by 2 is called -1 times 1 is -1. Add 3, you get 2. All right, 1/2 times 0 plus 3 more. Well, 0 plus 3 is usually 3. All right, just keep going. Okay, 1/2 of 2 is 1. 1 times 1 is 1 plus 3. That's usually 4, especially on Thursday. Is it Thursday, guys? Probably so. Okay, so just kidding. All right, so now here in this next one, 1/2 of 4 plus 3. 1/2 of 4 is 2. All right, 1/2 of 4 is usually 2, especially on Thursday. All right, plus 3 is 5. Look at the pattern that's going on. All right, and then 1/2 of 6 here. Oops. All right, and then add 3. So 1/2 times 6 is 1/2 of 6, which is usually 3. 3 plus 3 is 6, and the pattern continues. So you take 1/2 of 8 and then add 3. So notice I say that. I say it's really it's 1/2 times 8, but 1/2 times 8 is 1/2 of 8, and hopefully you guys see that. And that's 4. 4 and 3 is 7. Okay. All right. So let's take a look at the rate of change. Again, the rate of change is equal to delta y divided by delta x, just like the first one. So take a look at it. It's always delta y divided by delta x. Always, 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 guys. Okay, now delta x, what is that? Well, from -4 to -2 is a +2 because we're moving right on the number line. And then +2, and then +2. 2 to 4 is a +2. 4 to 6 is a +2. All right, so hopefully it's obvious that delta x is 2. Now delta y is 1 here. 1 plus 1 is usually 2. Plus 1 is 3. Plus 1 is 4. Plus 1 is 5. All right, so delta y is equal to 1. So the rate of change is 1 divided by 2. Okay, you take your delta y and obviously divided by delta x. And notice that's in the function. Okay, your rate of change, which is the value of m in this case, all right, is given in the function. Okay, so you should have already known that even before we got started, but I'm just trying to make connections here. All right, so now we plot -4 comma 1 is left 4 up 1. -2 comma 2 is left 2 up 2. 0 comma 3 is up 3. 2 comma 4 is right 2 up 4. And then 4 comma 5 is right 4 up 5. Excuse me. 4. 4 comma 5, right? 4 of 5, right there. Okay, and then 6 comma 6, and then 8 comma 7. All right, and then you'll notice that they are linear, right? They line up in a line. So draw your linear function. And that, my friends, is y is equal to 1 half x plus 3. And notice the y-intercept, okay? So the y-intercept is 3. The slope is 1 half. So again, rate of change is the same thing as slope, okay? All right, does that make sense, you guys? Does all this ring a bell? Because I'm just reviewing a lot from middle school right here. So you should have all seen this. It's the question is like, can we get really good at it so you can do it easily, all right, on your own, all right, without the aid of a calculator. Oh, and speaking of calculator, I'm going to bring in the Desmos. Okay, so let's check this out. This is going to be bitchin'. Okay, so bring Desmos up like this right here, off to the side. All right. Get out of there. Okay, so now type in the function, all right, y equals 1 divided by 2, which is 1 half. Go right arrow, type in 1 half x plus 3. Okay, just type it in. And you'll notice that we have a similar looking graph. Isn't that amazing? Look at that. All right, now watch this. I want you to screenshot it. All right, I don't know if I can do this in a video. Oh, I've never tried this. Okay, can I do this in a video? Let's see. All right, press copy and delete. All right, go over here, get rid of the calculator and put it off to the side. So click on text box right up there, press and hold, paste it in. Oh, you know what? Look at that. I can do this in a video. Check that out. That is super cool. Look at that. So on the right here, this is Desmos right here. Desmos. Notice that we have a y-intercept of 3 and intersects at -6 right here. Right here, and it goes up 1, right 2, up 1, right 2. So look at all the points on the graph. It's the same graph, guys. So you can use Desmos here to verify everything I'm saying. How cool is that? All right. Oh, and not only that, watch this. This is cool too. Let me show you something else. Okay, now we have the graph here. So what I'm going to do is click on the gear, all right, and select table and put the points in. So -6, all right, -3, 0, and 3, and then 6, and then 9. Ooh, now look at that. Now, doesn't this look familiar? Okay, so did I have 9 though? So let me bring this back up. I'm doing some serious Desmos iPad stuff here. Look at this. Oh, I typed in the wrong number, so let me change them. So -4, enter, -2, enter, 0, enter, okay, 2, and notice a pattern. Let's just click on enter, and look at that. Look at all the points, 1, 2, 3, 4, 5, 6. Oh my goodness, look at that, and they plotted them for you. Okay, let me grab this. Okay, watch this. I'm going to screenshot this and bring it into the lesson and show you this. I'll do this in class with you guys here. Press done, copy and delete. Click on the 3 dots up top and go full screen here. And then what you can do is paste it off to the side. So let me just paste it. Click on text box, paste it off to the side. Watch it. Here it is right here. And there's everything we did. All right, so let me get rid of the previous one here. Delete that. Delete this other stuff, and let's bring this side by side. Okay. This is some cool stuff. Look at this. Look at what you can do with the iPad. All right. Look at that. Everything that I just did by hand was done in Desmos. There's the function right here. All right. Here's the table of values that we developed by hand. Okay. Right through here. And of course, there's the graph. It's the same graph. Look at that. and I'm writing on the iPad. And this is the kind of stuff that you guys need to learn how to do. You need to do it by hand first and develop the mental skills, and then go over here and back it up with technology and verify everything you do. Because if you compare the graphs, guys, it's the same graph. All right, it intersects the x-axis at -6. You go up 1, right 2. Look at that. There's your slope. There's your slope. Up 1, right 2. Up 1, right 2. Up 1, right 2. Look at that. You can see the slope. Beautiful. Up 1, right 2. The slope is delta y divided by delta x, and it's equal to up 1, right 2, or 1/2. Look at that. And again, you can see that in the technology, and you can see that by hand. So you want to develop your skills first. So always do all this mentally, and then you back it up with the technology. And again, I'm using the program called Desmos. Okay, one of my favorite online. It's probably the world's best calculator, actually. I mean, it's amazing. Okay, so now you got to get good. So this is where we pause and play. All right, so pause the video and play when you're ready. So just don't, copy and take notes, because that doesn't help you. All right, all right. You need to practice, and if you practice and check, all right, check your work, all right, then you're going to get better. All right, but you're not going to get better unless you do that. All right, so pause the play, work through this, and when you're ready, after you've done the table, the rate of change in the graph, press play and check your work. All right, so here we go. Go for it. All right, I'm going to assume you're ready to go, so let's do it. All right, so -1/4, all right, times -8 minus 2. Now, I'm going to cancel out the negatives first, divide 8 by 4 to get 2. All right, 2 minus 2 is 0. All right, let's do it again. So we're going to take -1/4, all right, multiply by -4 and subtract 2. I'm going to cancel out the negatives. 4 divided by 4 is 1, right? 1/4 of 4 is 1, because 4 divided by 4 is 1. 1 minus 2 is -1. All right, -1/4 times 0 minus 2. What does that equal? Well, this is just 0. Anything times 0 is 0, and 0 minus 2 is -2. All right, so now -1/4 times 4 minus 2. Well, let me see. 4 divided by 4 is 1, times -1 is -1, and -1 minus 2, well, that's -3. All right, last one, -1/4 times 8 minus 2. All right, divide. 8 divided by 4 is 2, times -1 is -2, minus 2, well, guess what? That's -4. So my rate of change, which is always delta y divided by delta x, is the following. Okay, from -8 to -4 is you're adding 4 because you're going right on the number line. Okay, there's your delta x. From -4 to 4 is 4. From 0 to 4 is 4. From 4 to 8 is a change of 4. So delta x is equal to 4. We're adding 4 every time, guys. Now on this one here, from 0 to -1 is a -1. -1 minus 1 is -2. -1 is -3. -1 is -4. So delta y is -1. Okay, so what is the slope? Well, -1 divided by 4, or -1/4, which corresponds to the slope. Okay, so this is the slope, or what's called the rate of change. So when you count the rate of change, it's the slope of the linear function, okay, the slope of the line. And that's what you guys have to understand. Okay, now let's plot the points. Okay, I'm talking about 8 negative, oh, excuse me, I didn't say that correctly. So 8 comma 0, -4 comma -1, and so on. So 8 comma 0, -8 comma 0 is left 8. I'm going to plot these in red here. That's -8 comma 0. Negative 4 comma negative 1 is left 4 down 1. 0 comma negative 2 is down 2. 4 comma negative 3 is right 4 down 3. And then 8 comma negative 4 is right 8 down 4. And you can see your linear function. So let's graph the function here. Okay, and you can see what's going on. You go down 1, right 4, down 1, right 4, down 1, right 4, down 1, right 4, and that's rise over run. Rise divided by run, negative 1/4. Okay, down 1, right 4. And there's your slope, okay, which is called rate of change in general. Okay, and again, these are the skills that you need to get good at. You need to get good at arithmetic, rate of change, and of course, analyzing and graphing a function. And then, of course, these skills are going to be good or going to be used to, develop other skills, with more advanced functions, because we're going to study linear functions, quadratic functions, cubic functions, exponential functions. I mean, all sorts of things. So, fasten your seatbelts because we're gonna do it all. Because it's my job to get you guys ready. All right. So, and so that's why we're gonna be rigorous. Okay. Okay. So one more time, pause the video and play when you're ready. Okay. Again, pause. All right, and play when ready. Okay. Go for it. Okay. All right. So I'm going to assume you already did this, so let's try it. So we're going to take 1/3, all right, times whatever x is minus 2. So 1/3 times negative 6, and then, oh, I'm sorry, minus 2. Because again, the function is equal to 1/3 times whatever x is minus 2. We're just going to put it in red, just big and bold. Okay, so now negative 6 divided by 3 is called negative 2, minus 2 is negative 4. Once again, you have to be good at arithmetic. Negative 2 minus 2 is negative 4. All right, next one. 1/3 times negative 3 minus 2. What's that? Well, negative 3 divided by 3 is negative 1, and then minus 2 gives you negative 3. All right, 1/3 times 0 minus 2. Well, that's got to be negative 2 because, this part is just 0. 1/3 times 0 is 0, obviously, and 0 minus 2 is negative 2. So now let's take 1/3 of 3 minus 2. So 1/3 of 3, all right, 3 divided by 3 is 1. 1/3 of 3 is 1. 1 minus 2 is negative 1. All right, and now let's take 1/3 times 6 minus 2. Okay, at this point, we got 1/3 of 6, which is 2. 2 minus 2 is 0. Next one, we got 1/3 of 9 minus 2. So notice that I always write it first, and then I evaluate. 9 divided by 3 is 3. 3 times 1 is 3. 3 minus 2 is 1. Okay, so if we graph these points, negative 6 comma negative 4 is left 6 and down 4. Negative 3 comma negative 3 is left 3 down 3. 0 comma negative 2 is down 2. 3 negative 1 is right 3 down 1. And then 6 comma 0 is right 6, just right 6. And then 9 comma 1 is right 9, up 1. And then, of course, you draw your function. Okay, and there's your linear function. Y is equal to 1/3 x minus 2. So notice that this is the y-intercept here. And we got a slope up 1, right 3. Up 1, right 3. Up 1, right 3. Up 1, right 3. Again, it's rise over run. So this right here, you rise over run, your slope is 1/3. We go up 1, right 3. It's called the rate of change or the slope of your linear function. Okay, so your delta y, let's take a look, let's go further now. Okay, so let's find your delta x. Now your delta x is your change in x. So from -6 to -3, we add 3 because we're moving right on the number line. So -3 plus 3 is 0. Okay, if you keep adding 3, you get the next value. 3 plus 3 is 6. And then 6 plus 9 is 3. So your delta x, or your change in x, is 3. It's constant. How about your change in y? From -4 to -3 is +1. From -3 to -2 is +1. -2 plus 1 is -1. Plus 1 is 0. Plus 1 is 1. So your delta y is 1, and it's constant. And this always happens for linear functions. So your delta y divided by delta x, your rate of change, or the slope of the linear function, is equal to 1/3, which makes sense because I gave you the linear function here. Okay, this is your slope of the linear function. So you can see it in the function itself, you can see it in the graph, you can see it in the table. And what you guys need to do is remember that when you have a linear function, let's put this in red, y is equal to m times x plus b, which means y is equal to the slope, which is called the rate of change, times x plus some y-intercept, which is a number right there, which in this case is -2. So your y-intercept is -2 in this case, because that's where the line crosses the y-axis, okay? That vertical axis is called the y-intercept. Okay, so you should be able to see the slope of the line on the graph. You should be able to see the rate of change or the slope line in the table, and you should be able to see the slope or the rate of change in the function itself. So there's 3 representations right now of the function that I give you: the function, the table, and the graph. And you should be able to go from one to the other and understand the different qualities of everything. And that's what this whole lesson's about, okay? I know you guys saw it in middle school, but that doesn't mean you mastered anything, okay? Because it takes a lot of practice, as I keep saying to you guys every day. All right? Practice does not make perfect, but perfect practice does. So when you go home, practice this. You know, it's one thing watching a video and taking notes, but can you do this alone? Print off another copy, practice on your own, and prove to yourself that you can actually do this. You know, without a video, without a calculator, without Desmos, but purely on your own. Okay? So make yourself proud, go home, do the right thing, and practice. And I'll see you in class next time when I get back. You guys take care. Zanesworth, goodbye.